All right, metals, nonmetals, metalloids. So some classification, some properties. Let's get to it. All right, standards, objectives, pause it, peruse it, but let's move on. Metals. Most elements are metals. Left side of the periodic table, seen in blue here. So see, look how much blue there is. Most of the elements on the periodic table are in fact metals. And remember, metals tend to lose electrons when they form compounds. So some properties of metals, they're conductors of electricity, hence this little image. They are conductors of heat, that's why pots and pans are made of metal. They're ductile, so that means they can be squeezed out into a wire, like copper wiring. They can be malleable, so always think mallet, like a hammer. They can be hammered or rolled into sheets like aluminum foil. They have luster, shiny. They're solids except for mercury. One exception, mercury is the only liquid metal. All right, what are alloys? So we talked about this before, but just a reminder. So it's a solid or liquid mixture of two or more metals. Now, obviously, you couldn't take two solids and just mix them up. You would have to have melted it down, but then it could be re-hardened into a solid. So brass is an alloy of copper and zinc. And the reason is it's harder than copper, it's more corrosion resistant. So it is beneficial to use something that has properties from both metals. So brass is superior for those reasons. Sterling silver, obviously it compared to silver, it is more durable and less soft, so that gives it some strength. So sterling silver has some copper in it, but it gives it some additional properties that it wouldn't have without that copper being added. So an alloy, a mixture of two or more metals. It can be a solid or liquid mixture. And then steel is iron and like carbon, a little bit, 2% of carbon, plus other elements, depending what properties the builder would be looking for. All right, transition metals. They are groups 3 through 12. They're the D block. They do not have the same number of valence electrons in each group necessarily, so we don't focus on the valence electrons here. They're less reactive than the alkali metals and the alkaline earth metals. Some are among the least reactive elements, like gold, palladium, and platinum are very low on the reactivity. And they do have metallic properties, though, like they're conductors, they're ductile, they're malleable, they have luster, okay? So there's the transition metals, all right? So it's this D block right here. This, remember, is alkali metals, alkaline earth metals, okay? But here we're talking transition metals, that D block in the center of the periodic table. And then we have lanthanides. It's a part of period 6, so they're the F block elements, well, at least part of them. They're placed below the periodic table to keep it narrow. It's the first row and they follow lanthanum, so hence lanthanides. They're shiny metals. They kind of react like alkaline earth metals. So look, here, right here, lanthanides, and they're put down here, but you'll see in a little bit where they would be if they didn't break the periodic table like this. And then we have actinides, and that's part of period 7. They're also F block elements, again placed below the periodic table to keep it narrow intentionally. It's the second row in that bottom F block, and they follow actinium. These ones are all unstable. They're radioactive elements. Probably the most well-known radioactive metal would be uranium. So let's look here. So see, starting right here, the actinides, okay, again, found in this F block below the periodic table, but beginning here with actinium. So if we didn't cut that out, if we didn't make it a bottom block, this is what the periodic table would look like. So we see how it's stretched out longer. Everything that's written in there would get smaller. So just for ease of printing it on paper, the periodic table has the lanthanides and actinides below. But here is really where the lanthanides and actinides would belong if they were put into the periodic table in their correct location. Okay. And again, you can see, just as a reminder, alkali metals, alkaline earth metals, lanthanides and actinides. We have transition metals. We have nonmetals over here. We have noble gases, halogens. Down this, we have metalloids. These are also metals over here. Okay, so metal, 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 metals, metalloids, which we'll talk about, and then nonmetals over here. This one is noble gases. So these are some examples of metals. Remember, mercury, the only metal that is a liquid at room temperature. We've got silver, gold, palladium, rhenium, osmium, nickel, copper, whole lot. Okay, most of the periodic table. And you could see shiny, luster, malleable, ductile. Okay, conductors of heat, conductors of electricity. Those are kind of the big properties. And remember, they tend to lose. They give it up. Oh, whatever, fine, take it. Take it. I'm happier without it. Take it. They get their stability by losing those electrons. Nonmetals, on the other hand, are on the right side of the periodic table, except for hydrogen, kind of the oddball. And those nonmetals are seen in yellow here. So you can see a much smaller selection of elements. So the properties of nonmetals, instead of being conductors, they are insulators. So they do not conduct heat and electricity. They're dull, they're brittle, and they can be either a solid, a liquid, or a gas. So we have a wide variety in terms of states of matter. So here are some examples of nonmetals. Oxygen, a gas, bromine, a liquid. So that's going to be our only liquid nonmetal. So we have one liquid metal, mercury, one liquid nonmetal, bromine. But you can see we have gases, we have solids, and we have solids in varying states, from powders to something more hard like carbon and sulfur in this visual here. Metalloids. So metalloids, it's kind of like a metal, kind of like a nonmetal. So they're in between metals and nonmetals. Here they're seen in pink. Something that's interesting to note about them is the list of metalloids is not consistent across textbooks, across resource. So I'm going to kind of address that. You can see here our metals are in red, most of the periodic table, non-metals in blue, and then the metalloids in yellow. And you can see that's slightly different from what we just looked at. And again, slightly different from what I'm going to show you right now. Here you could see this just classifies the metals and nonmetals as other specific things, but you can see this right here. This bright green is representing metalloids, which looks different again. So sometimes these two are included, polonium and astatine, as metalloids. This group right here is always included. So let's look at another representation. Okay, this slide for some reason is taking me a million takes, but here we go. Let's try again. This as the periodic table as you're given it. And I want to talk about it because this is your reference. So let's look at the locations of solids, liquids, and gases. Almost every element on this periodic table is a solid, so I'm not going to focus on that. So let's focus on the exceptions. If I don't mention it, it's a solid. If I do mention it, it's either liquid or gas. So let's do gases first because we cover noble gases, all of group 18. Hydrogen, that is a gas. And then we have 4 more: nitrogen, oxygen, fluorine, and chlorine. So noble gases, gas, hydrogen, gas, and then NOFCl, gases. Okay. And then there are 2 liquids, 1 metal, 1 nonmetal. So remember we had F and Cl that were gases. The next one in the list, bromine, is a liquid, and then further down, those are solids. So bromine is the liquid non-metal, and Hg, or mercury, is the liquid metal. So hydrogen, group 18, NOFCl are gases, bromine and mercury are liquids. Everything else is a solid. But the real reason I'm going to show you this table is, see this line right here? This line separates metals and nonmetals. Metals is almost all of the periodic table, so that's everything over here. Nonmetals is a smaller section. But we do have elements that are considered metalloids, and they have to be touching this line. Not every element that touches the line is a metalloid, but it can't be one unless it is. So let's see what I mean by that. First one, boron, touches the line, metalloid. Si, touches the line, metalloid. Aluminum technically touches the line, but I always try and remind students, aluminum you should know is a metal. We make foil out of it, right? Then we have two elements right here that touch the line, GeAs, both metalloids. Then we have, here's the line, we have two elements that touch the line, Sb and Te, beautiful, metalloids. These are the only ones that are agreed on, that always, these ones, B, Si, Ge, As, Sb, Te, always metalloids. So the only one touching the line up here that is not a metalloid is aluminum. So that's the oddball. You gotta remember that one. Now down at the next period, so in period 6, we have two more elements right here. Sometimes they're referred to as metalloids, sometimes just one of them, sometimes both of them. So sometimes PO, sometimes AT, sometimes both, sometimes neither. So this is the exception. So these first 6, B, Si, Ge, As, Sb, and Te, must know those are metalloids. These two could kind of go either way. Seems to be kind of flip-floppy across the board. All right, so what are the properties of metalloids? Well, they have properties of both metals and nonmetals. So they're semiconductors. They kind of conduct electricity. They kind of conduct heat. They tend to be brittle, but they do tend to have luster. So again, some properties of both. So here are some metalloid examples. Silicone used in computer chips. That's probably the one that people might be most familiar with. All right, so quick refresher, again, solids, liquids, and gases. You can see them visually illustrated here. Blue are the liquids, yellow are the gases, and green are the solids. Okay, another example, blue are gases, the yellow are solids, the white are all metals, and then we have the lanthanides and actinides shaded differently. And then there are red boxes put around the artificially man-made elements on the periodic table. All right, so this type of element is a good conductor. Which one? Metals, right? Metals are good conductors of both electricity and heat. Okay, so you can see in this GIF, we get to wood, it doesn't light up. But we use other elements like copper, lights up, glass does not, steel, it does, metals, conductors. This type of element is usually dull and brittle. That would be a non-metal. This type of element has properties of both metals and nonmetals. That would be a metalloid. This type of element is a poor conductor. That would be a nonmetal, remember. This type of element is malleable. That would be a metal. We could also describe it as ductile, being able to be stretched out into a wire. And there you have it. That's metals, nonmetals, and metalloids. I hope you learned something new today.